Hi everyone, and welcome to Mike Likes Robots. Today we're going to be talking about AWS IoT SiteWise again. Last video, I'll link it at the top and in the description. I talked about what IoT SiteWise is and talked about a few different ways that you can get data in, but showed only one, which is using API calls. Today I want to show you how to create an IoT rule which can route data from IoT Core, and again, link at the top and in the description. Take data from IoT Core and put it into SiteWise. I'll be doing that in two ways, one directly through the console and also through the Cloud Development Kit, which I'll talk more about when we get to it. So let's get into it. So here we are in the SiteWise console. The first thing we want to do is double check that the models and assets we created in the last video are still active, because I want to use one of them as a guinea pig for the IoT rule. So we're going to open up this sidebar and show the models, and we can see that the robot fleet model and robot model are still here. The fleet model being a collection of robot models and a robot model containing a battery percentage along with some transforms and metrics. We won't be using the metrics and transforms this video, so let's move on to the assets. And we can see that there's still a fleet asset with 5 robot assets attached. If we take a look at robot 1, which we'll use as our guinea pig this time, we can see that the measurements has nothing for about a week. So this is a good guinea pig to show our IoT rule working. To set that up, we need to open the IoT Core console. And then we want to go to the message routing section, rules. Now an IoT rule is a way of selecting from a particular topic, including with wildcards, and taking that data and performing some action with it. The actions that are defined we'll look at when we create the rule, but some examples are creating a notification using SNS, putting it into a bucket, republishing it with AWS, or in our case, updating an asset property of SiteWise. So let's work through creating our rule. Our rule will be ingest from core. We will leave the description as it's optional. And this is how we select the data we want. So we're using a SQL-like syntax to select our data. So we can select multiple things at the same time and rename them for ease of use throughout the rest of the filter. We can do more advanced things like flattening out our data structures if we want. For our case, it's very simple. We're just going to select all the fields from within our MQTT message, which is just done using a star. We can select a topic filter. So the topic filter we're going to use is robots, followed by the fleet name, which we'll leave as a wildcard. It can be anything. Followed by the robot name, which again can be a wildcard, followed by battery. There's no condition where we don't want our rule to be active, so we can delete the rest of this line. Now this will trigger if an MQTT message comes in on, let's say, this topic. And our rule will try and take the data from that and read the fields, and if those exist, as in it's a valid message in the format we're expecting, it can format that and put it into SiteWise for the fleet robot. So the fleet named fleet, the robot named robot. Let's proceed to the next step. And now that we've determined what our SQL statement will be, we need to define what action to do with it. So feel free to create a rule and take a look at all of the available options here. One particularly flexible one is that you can format messages to give to Lambda, which lets you execute pretty much any code you want and do anything with any resources you want. So you can do pretty much anything from here using IoT rules passing into Lambda. And there's a lot of other options here. The option we want is nearer the bottom. It's send a message data to asset properties in AWS IoT SiteWise. It gives us all these blank fields to fill out. We have two options, by property alias and by asset ID and property ID. When we used API calls, we looked up the asset ID and property ID, but in this case, we're going to use a property alias. And I'll describe how to set that up once the rule has been created. So our property alias depends on the MQTT topic that we got in. We could create one rule for every robot and change it to be specific to the robot, but instead we'll format the correct property alias based on the MQTT topic. And the way we can do that is by entering the fields that are fixed and then using substitution for the other fields. So by doing a dollar with curly brackets, we can use the word topic to mean look up a particular field of the topic. So we want topic 2 and topic 3. That's because our topic, like robots, fleet, robot, battery, robots is 1, fleet is 2, robots is 3, and battery is 4. So we want the fleet as 2 and the robot as 3. So that will be our property alias formatted using our MQTT topic. Now the data that we need, we can also look up from the message that's been passed in. So all of our messages will contain the time in seconds directly from the message. This is instead of generating a timestamp at ingest time, because it's more correct that the robot will tell you when the measurement was taken rather than when the cloud receives it. So that's our time in seconds, and our data type will be integer because that's how we set up our model, and the value will be the battery. Now that's all we need for the message data. What we also need to do is set an IAM role. That's what gives our rule the permission it needs to interact with other AWS services. So in this case, we need to create a role that is allowed to update asset properties in SiteWise. Fortunately, if we create a new role, it will apply the configuration it needs. So let's create a role, like ingest role. Let's call it SiteWise ingest role. And we'll take a look at that role. So if we take a look at this, it has a trust relationship saying that the IoT service is allowed to assume it. That's required for the IoT rule to be allowed to use it. And it currently has no permissions. The permissions will be added to it when we finish creating the rule. There's also an optional field to add an error action. We're not going to do that to keep it simple, but you could if you wanted log a message in CloudWatch or store data in an S3 bucket. Take a number of actions if something goes wrong with the rule that allows you to better track down what's going wrong or track down the number of errors. So we'll proceed clicking next, and we'll look at the review. And there's an issue here, which is that the SQL statement doesn't have quotation marks around the from statement, which it needs. So let's go back to the review section, and that looks correct now. Okay, we'll click create, and then what we want to do before we move on is to double check that the permissions have been applied. And we can see that there's a new policy, an inline policy, which allows us access to update property values as well as time series. So those are the minimal permissions that are needed for this rule to work. Our next step of setup is to make sure that our aliases are set up in SiteWise. So what I'm going to do here is take a look at the robot1 asset, and I'm going to edit the alias here to match what the IoT rule will try to look up. So in this case, the fleet name is fleet1 and the robot name is robot1. So we're going to edit this, find the battery measurement and change it to /robots/fleet1/robot1/battery. That means that after setting up this alias, anytime something tries to push data into SiteWise using this property alias, it will go specifically to this asset with this property, instead of having to look up IDs from the console for the same effect. It will simplify our setup when it comes to our cloud development kit. So let's save that, and now it's time to test it. The way we're going to test it is to open up IoT Core's MQTT test client. And first we'll subscribe to all topics so that we can see our message once it's published. And then we want to write to the topic name robots one robot one battery. The message will contain the battery level, which will be 10%. And we also need to supply the time in seconds. Now for this, I'm just going to look up what the current time is online. Now when we publish this message, we can see it come through here. And here we can see the value has come through, our latest value 10. Now, while waiting for this to happen, it actually didn't happen with the permissions that I set. What I had to go and do is go into the SiteWise ingest role and add this new policy, AWS IoT SiteWise full access. I'm not sure what part of the attached policy wasn't doing it, but what I tend to do is err on the side of overly permissive policies and get it working to make sure everything is working end to end, and then narrow those policies back down. Now, in this case, because it's a demo, I won't do the restriction back down, but if I was to do that, then I would focus on removing this policy and taking this inline policy generated by the rule and figuring out what part of it needs to be modified to allow just the operations that I need. So with that, we have our IoT rule forwarding data into IoT SiteWise. Now let's take a look at the Cloud Development Kit. So what is the Cloud Development Kit, the CDK, and why would I want to use it? Well, what it does is it allows us to define infrastructure as code. If you've ever heard of that, it's a way of saying that you write code to develop what your cloud infrastructure will be. I can write CDK code that creates S3 buckets, IAM roles, SiteWise assets, and by doing it all in code, I can commit that using version control, I can ask other people to review it, I can share it with other people, and a number of other benefits. Just think that every time you want to update your cloud system, you commit some code of CDK, you get someone to review it, and then you automatically deploy it with continuous deployment. That's what you can do with infrastructure as code. CDK is not the only infrastructure as code tool out there. There's also Terraform as a popular one, but CDK is the one I have most familiarity with. So we're going to use CDK to construct a number of SiteWise assets and models and the IoT rule that we just set up in the console. So we're using CDK to automate everything from the past two videos. Let's take a look at how we can do that. The first step to understanding CDK, I would say, is this page. I'll link it in the description and I recommend you take a look at it. It's got a good number of key concepts, but the section we're interested in right now is install the AWS CDK. So what we want to do is make sure that we have npm on our system, and for an Ubuntu system that's pretty simple, we can just apt install it. And then we can do an npm install AWS CDK. That gives us all the tools we need to be able to create and deploy CDK projects. We also want to make sure that we've bootstrapped, which is the next section in this guide. So I'm not going to do that for my system because I've already done it, but if you're setting up for the first time, make sure not to forget this step. So let's take a look at our CDK code. This is another sample repository I'll make available in the description, and it is very similar to the last one. Our Python code is here, except that instead of giving a battery property ID and robot asset IDs, we're now giving a fleet name and robot names. And that's because we're going to publish messages using IoT Core using the robots, fleet, robot, battery topic that we use to set up the IoT rule. So this script is doing the same thing, but through IoT Core instead of directly through SiteWise. With that, let's take a look in the CDK directory. Now, a lot of this we can ignore. It's just stuff that NPM needs to understand what the project is and how to build it. What we're interested in is just in this lib folder. There's a lot of grayed out files. These are built from the TypeScript files. So again, we could ignore these. So the only files we need are the CDK stack, the asset models, the assets, and the IoT rule. So these files are what are defining the assets to create in SiteWise and the IoT rule to create in IoT Core. From our asset models, we are creating a robot CDK model with a battery percentage, just like we've already got, except that it's using a double data type instead of an integer. And we're also creating a fleet model, and we can inline create the hierarchies. So all of that clicking through from before, creating the model, the robot model, and then the fleet model, and then adding the hierarchy separately, we've just done in a single file here. Once the asset models have been created, we can start making assets from them. At the top of the file is defined a fleet with a list of robot names, and the same again here. So by updating this constant, we can create more fleets and more robots within those fleets purely from deploying the CDK project. It's also creating a property alias for the battery measurement. So instead of us going back into the robot asset afterwards and creating our alias manually, it's created automatically at the time of the CDK project deployment. Finally, our IoT rule file. What this is doing is creating a service role with the most permissive policy. And it's creating the rule, where the rule has the SQL statement we've got. You'll recognize robots ++ battery, and it's got an action defined. And the action, if you go back a few lines, is to update using a put asset property into robots topic 2, topic 3 battery. So we're seeing the CDK version of what we just set up manually within the console. The last file from our CDK stack is the main stack. And all this does is import the other files' contents and create them. So from here, we can enter the CDK directory and we can do a CDK synth. This will make sure that our project builds correctly and gives us the template file that we'll be using to deploy to the cloud. And we can see it's given us a template file that we can use. This is a valid CloudFormation template. We could take this and go into the AWS console and plug it into CloudFormation there, and it would create all our assets for us. But we can also use CDK to deploy it using the CDK deploy command. When we execute this, it will compare the template file with what already exists in the cloud and determine what needs to be created or destroyed to update that stack correctly. It's telling us that these changes are new, so if we accept the changes, then that will deploy our stack and create all our assets for us. Let's wait for this to complete, and then we'll take a look at the console and see what's been created. Our stack has finished deploying, and it took 1 minute to complete, just under. So let's just deploy again, and this is to show that it will look at what already exists, realize that everything has already been deployed, and say that there are no changes to deploy. We can see CDK stack, no changes. Let's take a look at what it's just created for us. Now, if we open the console and go into CloudFormation, this is the CDK stack. This is what our CDK project just deployed. Now, we could look in here and see all of the assets it's created, but given it's quite a small project, we can just go through and view the assets manually. So first, we have our IoT SiteWise. In our models section, we have two new models, the Robot CDK and the Fleet CDK models. The Robot CDK has a battery percentage measurement defined. We can also look at the assets and see that we've got a prod 001 fleet and a test 001 fleet. Test has 2 units and prod has 1. So these have been created automatically by our CDK, and we can add more just by changing our CDK. If we take a look at test unit 1, we can also take a look at the measurements tab and see that our alias has been constructed already. Finally, we'll look at IoT Core for the rule. In message routing rules, as before, we can see our new rule, SiteWise ingest. This is created by CDK. It's got the same contents as our other rule, except that our action has a new IAM role. This was also automatically created by CDK. So with 1 minute's worth of CDK deployment, we've saved ourselves all of that time clicking through console options and figuring out what the right thing to do is. So our setup is complete. Let's run that file again. Our main.py file, except this time it's publishing messages to IoT Core. We'll come out of the CDK directory, make sure we source our environment, and run the main file. Now we're posting 2 statuses at a time because we're only publishing for 2 robots. We could, if we wanted, update the CDK with more robots and then add the extra robot names here, but 2 is enough to show. Now if we take a look at the console, we can look first at the test client and make sure that those messages are coming through. And we can see every second that there's a couple of new battery messages coming in, 1 for each of the robots. So let's take a look at SiteWise. In our Assets tab, Test 1, Test Unit 1, we can take a look at our measurements and see that the battery value is being updated. So we've just used CDK to automate all of the console deployment that we've had to do manually up until now. Now that we've seen our CDK project working, we want to make sure that we clean up after ourselves. We want to destroy all of the assets that we've created. So we'll stop the script running, enter into the CDK folder again, and now instead of going through the console, trying to remember what we've created, we can execute CDK destroy. What this will do is look up all the assets that it's already created and try to destroy them all. Some assets have termination protection enabled, like S3 buckets. So this won't work for all resources, but in our case, all of our resources will be cleaned up properly. So we can wait for this delete to finish, and then we'll take another look at the console and see that all of the resources are gone. And with that, our stack is destroyed. If we take a look at the console, we've got a bunch of resource not found exceptions. So let's take a look at our assets, and our 2 new fleets, Test 1 and Prod 1, are gone, and our 2 new models are gone, as well as our IoT rule. The rule has disappeared here. So today we used an IoT rule to automate ingesting data from IoT Core into IoT SiteWise. We used the console to create that rule and the role that it needs. And we also use CDK to automate creating the SiteWise assets, models, rule, and role that we created manually using the console. We also discussed the advantages of CDK, like how you can commit it, review it, and automate deploying it, along with a number of other advantages that we can see in the documentation linked below. What we did do last video that we didn't do this video is to create the metrics and transforms for our robot battery health. So here's my challenge for you today. Check out the project from GitHub, including the CDK project, and see if you can extend it to also do the transforms and the metric definitions that we used last video to estimate battery health across the whole fleet. I hope that you enjoyed the video. Let me know what you thought and if there's anything else you'd like to learn about, and I'll see you in the next one.